An electrical panel located 3 feet in front of a deep sink may be a code violation, specifically if it's in a commercial laundry room setting. According to the National Electrical Code, electrical panels must not be installed within 3 feet of sinks unless they are adequately protected against moisture. A NEM-1 enclosure, as described, is generally not considered waterproof and therefore does not provide sufficient protection against moisture exposure from a sink. Relevant sections of the National Electrical Code address this issue. Specifically, National Electrical Code 404.8 covers installations near water, and National Electrical Code 408.5 addresses the location of electrical equipment relative to sinks. The potential hazards of having an unprotected electrical panel near a water source are significant. Firstly, water splashing or dripping onto the electrical panel can create a short circuit or pose a risk of electrical shock. Secondly, moisture can corrode electrical components within the panel, which could lead to malfunctions or even electrical fires. To comply with the National Electrical Code requirements, several solutions can be implemented. One option is to install a more moisture-resistant panel enclosure. For example, an NEM-4 or NEM-4X enclosure is designed to provide protection against splashing water and other environmental factors. Another solution is to relocate the electrical panel to a location that is at least 3 feet away from the sink, ensuring it is outside the zone where water exposure is likely. As an alternative, the panel could be protected from splashing or dripping water by using a splash guard or another suitable barrier to deflect water away from the enclosure. It is essential to consider that commercial laundry rooms are typically classified as damp locations. Damp locations have stricter requirements for electrical installations due to the increased risk of moisture exposure. Given the complexities of electrical code compliance and the potential safety hazards, the installation should be inspected by a qualified electrician. A qualified electrician can assess the specific circumstances, identify any code violations, and ensure that all applicable code requirements are met to guarantee a safe and compliant electrical installation. The considerations mentioned address fundamental electrical safety principles and compliance with recognized standards. Neglecting these guidelines can lead to dangerous situations, including electrical shocks, fires, and equipment damage. Furthermore, compliance with the National Electrical Code is essential for insurance purposes and to avoid potential legal liabilities in the event of an incident. Therefore, it is crucial to prioritize electrical safety and ensure that all electrical installations meet the necessary code requirements. Choosing a NEM enclosure depends on the environment it will be installed in. NEM-1 enclosures are intended for indoor use primarily to prevent contact with the enclosed equipment in general-purpose applications. NEM-2 enclosures are designed for indoor use to protect against dripping and light splashing of liquids. NEM-3 enclosures are constructed for either indoor or outdoor use to provide a degree of protection against rain, sleet, snow, and wind-blown dust. NEM-3R enclosures are constructed for either indoor or outdoor use to provide a degree of protection against rain, sleet, and snow. NEM-4 enclosures are constructed for either indoor or outdoor use to provide a degree of protection against splashing water, hose-directed water, and damage from ice formation. NEM-4X enclosures offer the same protection as NEM-4 enclosures but with the added benefit of corrosion resistance. NEM-5 enclosures are designed for indoor use and protect against settling airborne dust, lint, fibers, and flies. NEM-6 enclosures are constructed for either indoor or outdoor use, providing protection against temporary submersion in water. NEM-6P enclosures also provide protection against temporary submersion in water as well as hose-directed water and damage from ice formation. NEM-7 enclosures are designed for indoor use in hazardous locations, specifically those classified as Class 1 Groups A, B, C, or D. NEM-8 enclosures are designed for indoor use in hazardous locations that are classified as Class 1 Groups D. NEM-9 enclosures are designed for indoor use in hazardous locations classified as Class 2 Groups C, F, or G. NEM-10 enclosures meet the requirements of the Mine Safety and Health Administration. NEM-11 enclosures provide protection against corrosive liquids and the effects of dripping and splashing liquids. NEMA 12 enclosures are designed for indoor use and protect against dust, falling dirt, and dripping non-corrosive liquids. NEMA 13 enclosures are designed for indoor use and provide protection against dust, spraying of water, oil, and non-corrosive coolant. Always consult the manufacturer's specifications and the National Electrical Code to ensure the chosen enclosure meets the specific requirements of the installation environment and provides adequate protection for the electrical components it houses. The NEC, or National Electrical Code, is a comprehensive set of standards and guidelines for electrical installations in the United States. It is developed and updated by the National Fire Protection Association, also known as NFPA, and serves as a benchmark for safe electrical design, installation, and inspection to protect people and property from electrical hazards. The National Electrical Code covers a wide range of topics related to electrical systems, including wiring methods, overcurrent protection, grounding, equipment installation, and safety requirements. The main objectives of the National Electrical Code are firstly safety, ensuring that electrical installations are designed and installed in a manner that minimizes the risk of electrical shock, fire, and other hazards. Secondly, standardization, establishing uniform requirements for electrical installations to promote consistency and compatibility across different jurisdictions. Thirdly, compliance, providing a basis for electrical inspectors and authorities to enforce code requirements and verify that electrical installations meet minimum safety standards. The structure of the NEC is divided into chapters, articles, and sections, each addressing specific aspects of electrical systems. Chapters cover broad topics such as general requirements, wiring and protection, wiring methods and materials, equipment for general use, special occupancies, special equipment, and communications systems. Articles provide more detailed requirements for specific types of installations, equipment, or systems within each chapter. Sections offer specific rules and regulations related to particular aspects of electrical installations, such as conductor sizing, overcurrent protection requirements, grounding methods, and equipment clearances. The National Electrical Code is updated every 3 years through a consensus-based process involving input from industry experts, electrical engineers, contractors, inspectors, and other stakeholders. Proposed changes to the NEC are reviewed and debated by technical committees, and revisions are made to reflect new technologies, address emerging safety concerns, and improve the clarity and enforceability of the code. The NEC is widely adopted by state and local jurisdictions throughout the United States, and it serves as the legal basis for electrical inspections and enforcement. While the NEC provides comprehensive guidelines for electrical installations, it is not a design manual, and it is essential to consult with qualified electrical professionals to ensure that electrical systems are designed and installed in accordance with the NEC and other applicable standards. The NEC is an essential resource for anyone involved in electrical work, providing the knowledge and guidance necessary to ensure safe and reliable electrical installations that protect people and property from electrical hazards. Article 404 of the National Electrical Code specifically deals with switches and addresses requirements for the installation and use of switches in electrical systems. Key topics covered in Article 404 include firstly the type of switches, which specifies the types of switches permitted for use in different applications such as general use snap switches, dimmer switches, and isolating switches. Secondly, it covers the installation requirements, which outlines requirements for the installation of switches, including mounting height, accessibility, and location relative to other equipment and building elements. Thirdly, it covers the connection of switches, which provides guidance on the proper wiring and connection of switches, including the use of approved wiring methods and termination techniques. Fourthly, it covers the grounding requirements, which specifies grounding requirements for switches and associated equipment to ensure electrical safety and minimize the risk of electrical shock. Fifthly, it addresses the marking requirements, which outlines the marking requirements for switches, including voltage and current ratings and other relevant information. Sixthly, it covers the accessibility requirements, which addresses the accessibility requirements for switches, including requirements for clear working space and access to operable parts. Seventhly, it covers the installations near water, which specifies requirements for the installation of switches in wet or damp locations, including the use of weatherproof enclosures and ground fault circuit interrupter protection. Article 408 of the National Electrical Code specifically addresses switchboards, switchgear, and panel boards, and provides requirements for their installation and use in electrical systems. Key topics covered in Article 408 include firstly the general requirements, which outlines general requirements for the construction, installation, and marking of switchboards, switchgear, and panel boards. Secondly, it covers the installation requirements, which specifies requirements for the installation of switchboards, switchgear, and panel boards, including clearances, working space, and physical protection. Thirdly, it covers the overcurrent protection requirements, which provides guidance on the selection and installation of overcurrent protection devices, such as circuit breakers and fuses, for switchboards, switchgear, and panel boards. Fourthly, it covers the grounding requirements, which specifies grounding requirements for switchboards, switchgear, and panel boards to ensure electrical safety and minimize the risk of electrical shock. Fifthly, it covers the conductor requirements, which outlines requirements for the sizing and installation of conductors used in switchboards, switchgear, and panel boards. Sixthly, it covers the marking requirements, which addresses the marking requirements for switchboards, switchgear, and panel boards, including voltage and current ratings and other relevant information. Seventhly, it covers the accessibility requirements, which specifies the accessibility requirements for switchboards, switchgear, and panel boards, including requirements for clear working space and access to operable parts. Eighthly, it covers the location relative to easily ignitable material, which specifies requirements for the location of switchboards, switchgear, and panel boards relative to easily ignitable materials to minimize the risk of fire. The damp locations referenced are areas that are subject to moderate degrees of moisture. Locations such as partially protected locations under canopies, marquees, roofed open porches, and like locations, and interior locations subject to moderate degrees of moisture such as some basements, some barns, and cold storage warehouses. These locations require special considerations for electrical installations to prevent electrical hazards and ensure reliable operation. Electrical components used in damp locations must be suitable for such environments. They should be designed and constructed to prevent moisture from entering and causing corrosion or electrical faults. The National Electrical Code provides guidelines for selecting and installing electrical equipment in damp locations to minimize risks. Wiring methods used in damp locations must be moisture resistant. Cables and conductors should have appropriate insulation and be installed in a way that prevents water from entering enclosures or raceways. The use of corrosion-resistant materials is essential for electrical components in damp locations. Enclosures, fittings, and hardware should be made of materials that can withstand moisture and prevent rust or deterioration. Grounding is critical in damp locations to provide a path for fault current and protect against electrical shock. Grounding electrodes, conductors, and connections should be properly installed and maintained. Regular inspections of electrical systems in damp locations are necessary to identify and address any signs of moisture damage or corrosion. Maintenance should include cleaning, tightening connections, and replacing damaged components. The NEC requires the use of ground fault circuit interrupters in certain damp locations to protect against electrical shock. Ground fault circuit interrupters are designed to detect small imbalances in current and quickly disconnect power to prevent injury. Enclosures used in damp locations must be weatherproof or rain-tight to prevent water from entering and damaging electrical components. Enclosures should be properly sealed and gasketed. To comply with code requirements, it may be necessary to firstly install a more moisture-resistant panel enclosure, such as a NEM-4 or NEM-4X enclosure. Secondly, move the panel to a location at least 3 feet away from the sink. Or thirdly, protect the panel from splashing or dripping water using a splash guard or other barrier. A NEM-4 enclosure is designed to provide protection against splashing water and hose-directed water, making it suitable for damp environments where equipment may be exposed to moisture. An NEM-4X enclosure offers the same level of protection as NEM-4 enclosure but includes corrosion resistance, making it ideal for environments where exposure to corrosive substances is a concern. Moving the panel at least 3 feet away from the sink is a practical solution to minimize the risk of water exposure. By increasing the distance, the likelihood of water splashing or dripping onto the electrical panel is reduced. Splash guards or barriers can be installed to deflect water away from the electrical panel. These barriers create a physical barrier that prevents water from reaching the panel, providing an additional layer of protection against moisture. In the described situation, the existing electrical panel is located 3 feet away from a deep sink in a commercial laundry room, which could be a potential code violation based on NEC guidelines. To ensure compliance, it's important to assess whether the panel is adequately protected against moisture. The presence of a deep sink increases the risk of water splashing or dripping onto the panel, potentially causing electrical hazards. To mitigate the risk of water exposure, several protective measures can be taken. The selection of an appropriate solution will depend on factors such as the layout of the laundry room, the frequency of water use, and the level of protection required. A qualified electrician can assess the specific circumstances and recommend the most suitable solution for ensuring electrical safety and compliance with the National Electrical Code.